Hello and welcome. I'll be talking about MediAssist, which is our submission to the Finding Similar Patients Challenge at the BITSxLAMARATÓ, and it is a tool for automated keyword extraction and matching for the clinical domain. And Jaime and I are both early stage researchers with a project called Natural Language for Explainable AI, which is an EU-wide initiative focused on making artificial intelligence models more transparent. And so during the hackathon, we built an NLP pipeline for extraction and matching of keywords for the medical domain. And one strong point of the system is that it is fully interpretable, because we know that practitioners are often wary of using artificial intelligence and data science models due to lack of transparency and explainability. And the pipeline is as follows. Given a textual document containing medical records for a patient, the feature extractor takes care of identifying relevant keywords, which are then passed on to the feature matcher, which determines for a pair of documents a similarity score based on both semantic and lexical similarity. And now in more detail, first, the textual file is passed to the general feature extractor, which takes care of extracting demographic information such as patient's age and gender. And then it is determined whether or not it's a structured file or not. We noticed that a lot of the records followed a specific structure where there were separate sections for the physical exam, symptoms, and treatment and such. And so if the document follows that structure, then we pass it on to a more robust and advanced section parser, which then extracts medical history, symptoms, and other specific keywords related to different specific sections in the medical record. And otherwise, we fall back on an unstructured feature extraction, which uses pattern matching to still assign to some keywords what part of the medical record they relate to, such as symptoms and evolution. And our feature extraction is based on syntax pattern matching, and we also have a way of handling negation. So basically, features that appear in the context of negation are discarded. And finally, we use a word frequency filter to filter out non-medical terms, because we notice that medical terms tend to be less frequent words. So we define a threshold above which we are not considering words a meaningful match. And this results in a set of document features. So as an example, here on the left you can see a patient's record, and on the right the relevant keywords that got extracted based on our feature extractor related to medical history, symptoms, tests, treatment, and so on. And so we can see that it was able to identify a lot of the meaningful keywords of this document. And then these keywords are passed further to the feature matcher, which, given two sets of keywords from two different documents, computes a semantic similarity and a lexical similarity score. So the lexical matching algorithm assigns a higher score to two keywords that are less frequent and have a longer shared substrings. And as a result, we can see that words that are more likely to be a meaningful match also contribute more to the overall lexical similarity score. On the other hand, we have a semantic matcher, which is based on spacey embeddings, and it also computes semantic similarity between two sets of keywords by feature type. And here again, pairs with higher semantic similarity contribute more to the overall semantic similarity score of the documents. And as an example here, on the left we can see features of two patients, and on the right we can see what similarity scores got assigned for each of the sections to these two patients, and then also we can see what pairs of keywords contributed and how much. And for the lexical contributions, our tool is able to detect that even words that don't look identical on the surface, such as thoracoabdominal and thoracoabdominal-pelvical, they're still assigned a very high similarity score and a high contribution to the overall lexical similarity score of the document. And similarly for the semantic contributions, it is able to detect the similarity for the abdominal lesion, for instance, between two keywords that on the surface don't look similar but have a very similar meaning. And it's important to say that these scores are relative. So it would be, patient A would be considered more similar to a patient B than patient C. But the score 2.7 on itself, in itself probably isn't very telling. And this is also convenient in the sense that a practitioner can, for instance, if they're interested in similar medical history, they can just filter all the patients by the similarity score in just that section, for instance, and then they can also see what matches there are. So why our algorithm thinks that these two patients, for instance, are similar. So that is our project, and we hope that it can be, maybe with some further improvement, be put to good use, and we look forward to opportunities for possible collaboration, so feel free to get in touch. And thank you for your time.